Kia ora koutou, Reese from QuickSense here, and today we're looking at calculating probability of more than one event. In this question, a boy is rolling a pair of normal dice, so that's a six-sided dice. What is the probability that the numbers on both are greater than 4? So the way we're going to do this is we're going to do a sample space again, which is where we write down all the possible combinations. So these are the possible outcomes on my first die, and the possible outcomes on my second die. So what we care about are the cases when both dies are greater than 4, so 5 and 6. And so what I do is I go through this, 1 and 1, that doesn't work, 1 and 2, that doesn't work, and actually we can see that this whole corner of the space doesn't work. And how many crosses are there in there? Let's get rid of these. Well, it's 1, 2, 3, 4 by 1, 2, 3, 4. So there are 16 crosses here. What we're left with are all the cases where it is greater than 4. So 5 and 5, or 5 and 6, or 6 and 6. And that's all of this space down here. And this space here is 36, 6 times 6, take away 16, which comes to 20 out of 36. So what's the probability? Well, the probability is 20 out of 36. In this question here, we're actually given the probability of certain events. So the probability that Mike is watching TV is 0.8, that Linda watches TV is 0.9, and the probability that they both watch TV is 0.75. And so you can see that there's going to be an overlap, right? Because the probability that Mike watches TV includes the time that he watches TV and Linda's watching TV, and where only he is watching TV. So the way to account for these overlaps is to use a Venn diagram. And our Venn diagram is going to look like this. Doesn't matter if it's perfect, but this area in the middle, right? This area in the middle is actually this. It's when they are both watching TV. Mike's here, 0.8. Well, that's this whole circle here. And then Linda, well, that's this whole circle here. Well, what's the probability that at least one of them is watching? Well, that's that whole overlapping area, right? So let's use another color to just represent that, right? That's everything in here. So how do I account for that? Well, the best way to do it, and the thing I want to avoid, is double counting that middle part, right? Because if I have the probability that Mike is watching TV, well, that's 0.8, but that includes that yellow part. So when I add that to the green part, so let's just keep track of these. So when I add that to the green part, which is 0.9, okay, so we've got the green part there, what I'm doing effectively is double counting the overlap, and so I need to subtract that. So that takes me 0.75, and that comes out to 0.95. So more generally, right, we've got P that M is watching TV plus the probability that Linda is watching TV minus the probability that Mike and Linda are watching TV. Well, that's equal to the probability that Mike or the union Linda is watching TV. And the answer, once more, is 0.95.